All right, third grade team, you made it to Unit 7. Oh yeah, we are finishing this thing. All right, so Unit 7 has three main things. First thing, multiplying beyond 10 times 10. So it gives third graders a little dive into what they'll be doing in fourth grade with their basic multiplication facts by making use of partial products and the area model. And then practice it. Yeah, that's pretty much it. Okay. And then second thing is fractions. Yes, you've done a lot. You actually do a lot of fraction work via Number Corner and in math lessons, Bridges regular math lessons with fractions. So third graders get a lot of experience with fractions, and now you're experiencing it even more. So just practicing with hops and stuff, practice pages from intervention materials, and then linking division with fractions and seeing what fractions have to do with division. Okay, so extending it just a little tiny bit. And then taking fractions into collecting data. All right, with circle graphs. So to start off with, the Smartboard file here will take you through everything that you need for multiplying beyond 10 by 10. So let's take a look at that. So if I go down to my Smartboard file down here, let's see this one. I do have a warm-up problem from last year that's going through two methods for subtracting numbers or adding numbers. So some computation in the warm-up if you want to use those. This one even has a video to follow along for another method, the algorithm. Okay. All right. It does kind of start you off Unit 7 with some wordy problems where you're trying to come up with an equation that would represent the situation. So that's how I have you start the time together. So they're going to get a situation that you go through sentence by sentence. We try to make sense of this problem and persevere through it by drawing what we're noticing. Okay, they put 6 chairs at each of the 5 tables. So I'm going to be like, okay, I have 5 things, and at each of those tables, there's 6 chairs. So they could literally draw the chairs around it, or they could just write the number 6 at each rectangle. And then 8 chairs at the big table. So now I have a bigger rectangle, and that one has 8 in it. Okay, so this is making use of a drawing to help us come up and make sense of this problem and figure out which equation would actually represent the situation. So you're just taking a couple days to go through a couple of situations and saying which equation will describe that. Okay, so that has 2 days of that. If I keep going, then I am into multiplying beyond 10 times 10. So now, okay, so it starts off with this picture, and I've worked extensively with Greg Tang resources. I know I have given you lots of Greg Tang games to use on his website, and this is him saying this is the gist of like how kids should practice when multiplying by bigger numbers, is thinking of multiplying using the area, what's on the inside. So when we think of multiplying, we need to think about that area. So if we have this picture, this is 4 groups of something. 4 groups of what? Well, here you're literally going to have to count 1, 2, 3, 4, 5, 6, 7. It's kind of hard to count, right? It takes a long time. Whereas if I put this on there, it's probably a little easier for people to get that number of 12. Instead of going one by one, they could go, oh yeah, that's 10, and then 2 more, that's 12. But then this is going to be even easier if I make the 10s one color and make the other part another color. So that's the whole idea. We're going to take 4 times 12, or 4 groups of 12, and use an area model to help us figure it out. So I have 4, I'm going to take my 12 and split it up into numbers that are nicer. I'm going to take that 10 out of it, the 10ness out of the number, and then I'm going to take the rest out. And then I say, well, this part right here was this part in our picture. right? How many squares was that? Well, that was 10, 10, 10, and 10. That was 4 groups of 10. That was my part of my area, 4 times 10, which is 40. And then my other part were all those twos in my picture, which were right here, all those twos. And I had 4 groups of 2. So that's what's existing in that area. So that's why I wrote my part, my partial product down here, and then I add them together. So this is a good part to discuss. Well, 4 times 10, that's nice, that's 40. And then 4 times 2, instead of just saying, well, I memorized it, it's 8, let's talk strategy. These are 3rd graders. We want to be flexible with numbers. It makes us stronger in number sense. So how could we figure out 4 times 2? Yeah, we could go 4 2 times. We could go count by 2s 4 times. We could, I like to put up 2 groups. And I'm going to touch each group. Each group is 4. This is 4 and this is 4. So if I put those 4s together, that's 8. Okay, and then if I add that together, 40 and 8 more is 48. So you just do these types of problems over and over and over and over and over again, as Greg Tang would say. That's how we get better. Practice. So I give them another one. And I draw that area model to see what's on the inside. And we list out our parts, our partial products. So I'm going to have 4 times 10, and I'm going to have 4 times 5. We talk about strategy, and then I give them another one, and then I give them another one. Okay? So you just spend a few days on that, and you just keep giving them a single-digit number times a teen number, and get them good with doing that, or feeling sort of comfortable with that. There are some more computational warm-ups for you to pick from. And then instead of just multiplying by a single digit times a teen number, now we can look at something like this. So this is 4 groups of what? So instead of a teen number, this is 4 groups of a tens number. This is 4 groups of 20. But we can really, as Greg Tang would say, think of it as 4 groups of 2 tens. So that 20 is really the same thing as 2 tens. And why does that help us? Because now we can just do 4 times 2, and that's 8. And 8 tens, well, that's 80. All right, so we work through all these that same way. So we go through another example and say, okay, well, what about this one? This one's 4 groups of what? 4 groups of 30. So I have 4 times 3 tens. 30 is the same thing as 3 tens. So we really just need to do 4 times 3, which is 12. But 12 tens, if we count by 10 12 times, guess what? We're going to be at the number with 12 and a 0 at the end. That's 120. Okay, so we're just, in order to get better at those types of problems, we just need to practice them over and over and over again. So then I have some practice sheets for you that look like this, where they can go through on grids and try it and see those numbers on there. And then trying some with just straight up equations and writing in that 4 factor. You could switch that to another factor. There's more computational warm-ups, more multiplying by multiples of tens numbers practice on there for you. And just more practice problems like this to say, okay, now if I have 10 times 4, what if I have 20 times 5? Well, I can really just do 2 times 5. Well, because 2 is 2 tens times 5, which is 10 tens, which is 100. So that is the gist of the multiplication. Okay? If I step into the fraction stuff, the fraction file is a new Smartboard file, and it begins by hopping on paper. I've had you hop on the floor before, but when you have a lot of students in your class, that becomes hard. So if you just have them have a regular piece of paper, landscape, I give them a game marker, and then we have a color, like a colored pencil. And we all color, we all take one line straight down the middle, and that's going to represent what? Half. Okay, so now we're going to practice hopping. I want you to go to 0 halves. Where are you going to go? Right here. I'm going to have you go to 1 half. Where are you going to go? Here. I'm going to have you go to 2 halves. Where are you going to go? Here. That's all the way across the paper. That's the whole paper you hopped across. Okay, let's go back to half. Oh, there it is. Let's go to 0 halves. Boom. Let's go to 2 halves. Oh, all the way across the paper. 1 whole paper. 1. Okay, so that's just practicing without hopping on the floor. Then I'm going to have them pick up another color and say, okay, now I want you to cut those halves in half. And now, if we cut a half in half, then we actually have fourths. So now let's practice hopping those. And I go through. Once I hit like 2 fourths, they're going to notice and say, oh, that's the same as a half. Oh my gosh, you guys. Yeah, 2/4 is the same equivalent to 1/2. So keep going. I work it, right? All right. Then I would proceed with a 2 fraction tasks. So this number line is perfect because we just hopped it on the paper. And then do some work with that. And now I'm going to pick up a ruler and take just a strip of paper that you have pre-made, ready to go. And we do what it says. Okay, and we can finish with a fraction comparison problem, or we could finish the day with a fraction practice page. And these are great practice pages from the intervention materials that I got for you. Okay, so each day looks like that, fraction hopping on paper, and then see how the next day we take what we did from the day before, we pick up a new color, and now we cut those fourths in half with a new color. And now if we take fourths and cut those in half, now we have eighths. So now we're hopping stuff there and noticing, okay? And then we have our same tasks to do, all right? So if we keep going and keep going and keep going, at the end here, I give you, we used this before, but it's mealworms, saying, want a bite of mealworms? Yeah, a burger made out of mealworms. So we read this cool, gross article, and then we do some math with it. Okay, so I took that article and I made the questions right here for it. So they're nice, more nicely laid out. Working fractions with insects. And then we finish the fraction stuff with pizza situations. So if you keep going in the Smartboard file, I have just the picture of pizza and say, what? This has to do with fractions? How? So you talk about it as a class, and then you give them this situation. All right, we have 1 pizza, and we're going to split it between 4 kids. And if we're all going to get the same amount, each person gets how much? So then we look at division as a fraction. So watch this. We're going to take 1 pizza and divide it, share it amongst 4 kids. Well, each kid is going to get 1/4 of the pizza. Isn't that weird? Look at that division and how it morphed itself into a fraction. So the division sign is the same as a fraction bar. A fraction bar really represents division. How cool is that? Okay, let's keep going. What if we have 1 pizza split between 3 kids? Then how much is each person going to get? Well, we have 1 pizza divided amongst 3 kids. We split it up in this picture here. They're able to say, oh yeah, that represents 1/3. Yeah, and look at that. That's what happens. That's what we see in our division. It's 1/3. And then we do it again, but this time we make it a tad tougher. We have 2 pizzas split between 3 kids. Well, first, let's go over here and say, well, 2 pizzas split amongst 3 kids. That's 2 fraction bar 3, 2/3 of a pizza, meaning let's split these pizzas up into thirds. So then I'd go through and I'd split it up with them into thirds with the marker. I'd split it up into thirds. Boom, boom, boom. And I'd say this kid gets this much. Then I have another, I'm going to split this one into thirds. So that's 1 kid. 2 kids, second kid gets this one and this one. Then third kid gets this third and this third. Did it work out? Yeah, each kid got 2/3 of a pizza. So they got a little less than a whole pizza. So let's try another one. How about 4 pizzas split between 3 kids? How much is each person going to get? We go through what it looks like over here, and now we make sense of it. What will that look like? And then we notice that that's the same as 1 1/3 pizza. So you're actually going to get 1 whole pizza and another third. So we're going to have to split these pizzas up over here into thirds to see how that's going to work. So that's taking your fraction work and extending it just a tad bit more for them to see how fractions and division relate to each other. Okay. All right. And then we go into linking data with fractions. So now you're collecting data. So you're going to take some surveys each day, and you only use 12 respondents. And you put them into a circle graph to represent the data. Here are the PDFs right here to look through. And you come up with a question. For example, what did you eat for lunch? Did you have a sandwich or something else? And I'm going to walk around the room and collect my data. And I'm only going to ask 12 people. Okay, and then I put my results on a circle graph and I color in how many people said sandwich and I color in how many people said something else. And then we're able to get fractions out of it and see it on a circle graph. Another way to do it, and we can look at everybody's circle graph and see what they were asking each other. And another way to do it is called the pull-in graph. So instead of asking a question, we have a bag pre-filled with tiles, just 2 colored tiles and only 12 tiles. And they get to put what they pulled out of the bag. Okay? All right. Good luck. Go forth. Math on.